All right. So rather than just answer the question, what I'd like to do here is show how sine function can describe circular motion. Okay, we have a Ferris wheel, and that's a good example of real-life circular motion. So this Ferris wheel has a diameter of 35 meters. Okay, the lowest point is 3 meters above the ground, and it finishes one full revolution in 8 minutes. So this is all we need to make a sine function. Okay. Your question in particular asks for the amplitude, the midline, and the period. The period is given, it's just 8 minutes, so that's all there is to that. But let's look now at how we can make a sine function. From there, we'll get the other information. Okay, so we have a Ferris wheel on the left, got axes here on the right. The x-axis is time in minutes. The y-axis is the height in meters. And what we're going to be interested in here is the maximum point on the Ferris wheel, the midpoint, and the minimum. Okay. So from the information given, try to think about what these heights could be. Okay. Maybe you write down some ideas. And here to the right, we have a sine function in its general form, where A is the amplitude, B is the frequency, phi is a phase shift, and C is a vertical shift. Now, let's run this Ferris wheel and see how the dot here is tracking the height. Okay. We reach a maximum there, back down. Okay, so this is a sine function, and we need to find out what those parameters are, A, B, C, and phi. Okay. So we can put in our particular numbers here. This is going to help us get some of the parameters. Okay, so maybe I'll pause it. We know that it's 3 meters off the ground. That's given. We know the distance to the midline because we know the radius. The radius is 17.5. And then we also know the maximum, which is another 17.5 from the midpoint. Okay. Let's run it one more time and just see how this curve does describe the circular motion. Okay. Good. All right. So what we can see is that the midline is the midpoint here, which is 20.5. So that's going to be C. The amplitude is the distance from the midline to the maximum, or the distance to the minimum. Okay, so that's that's the radius, half of the diameter. B is the frequency, which we'll get from the period, which is 8. And the phase shift is going to shift it to the left or the right. Okay, so now what I would recommend you do is go to Desmos. I'll send a link to this actual graph so you can just use this. But here's the general form of a sine function. Okay, and you can play with these parameters. This is the amplitude. Okay, and we said the amplitude is the radius. Okay, here's the period, set at 8 minutes, but you can change that and see what happens. And likewise, B is what goes here. It's based on the period. Okay, H is the phase shift. Just shifts it over. And then C. C should be just vertical shift. Okay, you could put a slider in for that as well. Okay, so anyway, I hope that helps. And once you get your function set up, you can get the amplitude from there, the midline from there. You can send your answers to us, and we'll take a look and see how you did. All right, hope that helped.